Hello, Matt G4IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 58, which reads, a home-made transmitter uses a crystal at 3.5 MHz multiplied up to 28 MHz. The crystal is specified as 0.5 ppm parts per million per degree C. At switch on, the room is at 18 degrees C, but inside the transmitter case is 36 degrees C when warmed up. How much will the transmitted frequency vary in that time? And we're given some values to choose from. So let's ignore the 28 MHz part for now and just concentrate on this crystal. And we're told that it is specified as 0.5 parts per million per degree C. And what that means is, well, we've got our crystal is running at 3.5 MHz, 3.5 million hertz, and 0.5 ppm per degree C means that it will be 0.5 parts per million out per degree C, or in the case of our 3.5 MHz crystal, it will be 0.5 hertz, half a hertz out for every degree C temperature change. Now this is 0.5 parts per million, and we have to account for the fact that our crystal is running at 3.5 MHz, so it's actually running at 3.5 million hertz. So for every degree C for our 3.5 MHz crystal, it's in fact going to be out by 0.5 times 3.5, which is 1.75. So for every degree C, because we've not just got it's parts per million and we've got multiple millions here, for every degree C it's going to actually be out by 1.75 hertz. So now let's think about the temperature change. Well, we know the temperature goes from 18 degrees C to 36 degrees C, so that's a temperature change of 18 degrees C, and we know that for every degree C that the crystal is going to be out by 1.75 hertz, so we do 1.75 times 18, and that's going to give us 31.5 hertz off frequency by the time that crystal is fully warmed up. So now on to the next part. We know that the output from the crystal oscillator is being multiplied up to 28 MHz, but that will also include the error, this 31.5 hertz error, once the case is fully warmed up to 36 degrees C. So let's figure out the multiplication ratio from 3.5 to 28, so that's 28 divided by 3.5, which is 8 times. So that 3.5 is being multiplied 8 times to get to 28, and let's also multiply our error by 8 times, so 8 times 31.5, which gives us a value of 252 hertz. So that 3.5 megahertz crystal output, after being multiplied up to 28 megahertz, and after the transmitter case has warmed up by 18 degrees C to 36 degrees C, is now going to be off by a total of 252 hertz, which is option A. Let's scroll down to the answers and see if we've got that one right. And yes, of course, for question 58, it is option A. Thank you very much. I'll catch you for the next one.